exact differential equation. Among all the types of first order, first degree DE, the most important one is exact DE. So, a DE, what is exact differential equation? A DE in the form, a DE, a differential equation in the form m dx plus n dy equal to 0 is said to be exact, is said to be exact DE if dou m by dou y is equal to dou n by dou x. This is the key point to decide the given first order first degree differential equation is in exact form. Dou m by dou y equal to dou n by dou x. Dou m by dou y equal to dou n by dou x. Then we say that the given differential equation is in the form, is in exact form. Whenever you have a differential equation in this form, m dx plus n dy form, first write m and n. After writing capital M is nothing, dx coefficient, capital N is nothing, dy coefficient. Find out m and n and find out dou m by dou y and dou n by dou x. If these two are equal, then the DE is in exact form. If they are not equal, then reduce it to exact if possible. That also we'll discuss. Whenever dou m by dou y equal to dou n by dou x, then given ordinary differential equation of first order and first degree is in exact. If the DE is in exact, what is its general solution? General solution of exact DE, exact differential equation, is integral m dx, keep y constant, keeping y constant, plus integral terms free from x in n dy plus c equal to 0. So here, very easy one, very most important formula. Integral m dx, m means dx coefficient, that one you need to write, the total term. But while integrating, keep y constant, this is important. If you have xy here, don't integrate y. In line integral, what happens, if you have y, convert it in terms of x, if you are doing with respect to x. But here no need. If you have y, keep that one as constant, don't integrate. Integrate x terms only in m. Coming to here, terms free from x in n. In n, you need to identify the terms which do not contain x. If you want, you can understand this one like this also. Terms do not contain x. Do not contain x in n. This is the exact meaning of terms free from x. If you have two terms in n, find out in which term you don't have x. That term only you need to write here. If you don't find that type of terms which do not have x, then simply keep here 0. If you find these type of terms, which type of terms? Terms do not contain x in n. That type of terms, if you have in n, you will write here and you will integrate. If you don't find that type of terms, simply you will keep 0 here. Okay, so which is very most important for short answer. We are going to discuss few problems in this so that you can understand how these two will be equal, how we are going to integrate m keeping y constant, how we are going to find the terms do not contain x in n. Okay. solve e power y plus 1 cos x dx plus e power y sin x dy equal to 0. So this is direct one, which is in this form. This is m, this complete term, this is m. So we have m dx plus n dy form. So which is directly in m dx plus n dy form. To decide whether that is exact or not, you need to find dou m by dou y and dou n by dou x. Before that, note down what is m and what is n. Keep this point in your mind. M is dx coefficient, n is dy coefficient. Sometimes dy may be given first, dx may be given next. So you need to identify what is dx coefficient, that is m. What is dy coefficient, that is n. Simply don't write the first one as m, second one as n. So here very clear, dx coefficient is m, which is in this form, e power y plus 1 into cos x. So dy coefficient is e power y into sin x. Now multiply this one so that you can differentiate very easily. E power y into cos x, e power y cos x plus 1 into cos x, cos x. This is m exactly. So we need to find dou m by dou y. Dou m by dou y means differentiate m partially with respect to y. Partially with respect to y means differentiate y terms only, don't differentiate x. Keep x as constant. That is partial differentiation. But while differentiating n with respect to x partially, here differentiate x terms only, don't differentiate y. That is partial. What I am saying, if you want to differentiate m partially with respect to y, keep x as constant. Don't differentiate x terms. If you don't find any y term in a term, keep that one as constant. Differentiation of constant is 0. So see here, do you have y term here? Yes, we have y term, that is e power y. Differentiation of e power x, e power x. So differentiation of e power y is e power y. Don't differentiate cos x, simply keep that one as constant and write like this. If it is in product. This is second term. In this term, do you have y? No, you don't have y term. Then keep that one as constant. What is differentiation of constant? Differentiation of constant is 0. So what left over? E power y cos x. So this is dou m by dou y. Similarly, find out dou capital N by dou x. Differentiate n partially with respect to x. That is, differentiate x terms only, don't differentiate y. So see here, if you have y term, keep that one as constant, don't differentiate if it is in same term. If it is in separate term, differentiation of constant is 0. When y term is in product with x, simply keep like this. Differentiate side. Differentiation of sin x cos x. D by dx of sin x cos x. So this is dou n by dou x. Tell me what is dou m by dou y? E power y cos x. What is dou n by dou x? E power y cos x. These two are equal. That means dou m by dou y equal to dou n by dou x. Dou m by dou y equal to dou n by dou x. So what we can decide? Given d is exact. Given differential equation is exact dE. Exact dE. Now, whenever given d is exact, then the formula to find general solution of given d is integral m dx keeping y constant plus integral terms free from x in n dy plus c. Integral, what is m? You can note down m completely. E power y cos x plus cos x dx plus terms free from x. Terms do not contain x in n. In n you have only one term. In n you have only one term. In this term, if you have x, don't write. We have only one term, in that we have x. That means terms do not contain x in n or zero terms. There are no terms in n which do not contain x. So 0 dy. Now keeping y constant, don't integrate y. So keep that one as constant. Integral cos x is sin x. Integral cos sine. After integration, you need to add plus c, indefinite integration without limits. Take sin x common, e power y plus 1 into sin x plus c equal to 0. Okay. So this is the answer for given exact differential equation. Simply write m and n, check whether dou m by dou y equal to dou m by dou x or not, then write general solution. Very most important for short answer, for external. We can expect 1% definitely from exact. So solve y square minus 2xy dx equal to x square minus 2xy dy. First rearrange the given dE to get the exact mdx plus ndy form. So I am taking RHS terms to LHS. Y square minus 2xy dx minus x square minus 2xy dy. Because this is plus, if you take to LHS, it will become minus. But to get plus here, I am multiplying this term with minus. Then what happens? Y square minus 2xy dx plus minus into minus plus. Plus term I am writing first. Minus into minus plus. 2xy I am writing first. Minus into plus. If you don't find any sign there, you have plus. Minus into plus minus x square dy equal to 0. Here also equal to 0. So now this is exactly in the form mdx plus ndy form. mdx plus ndy. Now write m and n. Capital M equal to y square minus 2xy. Capital N equal to 2xy minus x square. Now find out dou capital M by dou y. Differentiate m partially with respect to y. That means differentiate y terms only, don't differentiate x. Differentiation of y square to y. Differentiation of y 1 to x. Differentiation of y1, differentiation of y square to y, keeping x constant, don't differentiate x. So coming to here, dou n by dou x. That means differentiate n partially with respect to x. Differentiate x terms only, don't differentiate y. Differentiation of x is 1 to y. Differentiation of x square is 2x. Differentiation of x square is 2x. Differentiation of x is 1. Differentiation of x square is 2x, keeping y constant. Now, if you observe, dou m by dou y equal to dou n by dou x. When dou m by dou y equal to dou n by dou x, we can say given dE is exact dE. Given differential equation is exact. So we need to find general solution. So general solution of given dE, the formula is integral m dx keeping y constant plus integral terms free from x in n dy plus c equal to 0. This one, if you want, you can write in different way. Terms do not contain x in n. If you can understand that one easily, you can write that one also. First one, integral m dx. What is m? Y square minus 2xy dx plus integral terms free from x in n. Terms which do not contain x in n. In n we have two terms. In n we have two terms. Find out the terms do not contain x. In first term do you have x? Yes. In the second term do you have x? Yes. So you don't have, the terms do not contain x in n. So keep 0. Now integrate keeping y constant. Don't integrate y. Y square constant. You don't have any term here, x term. Then you may have 1. Integral 1 dx is x. So after integration you will get x here, xy square minus 2 into y constant. Integral x is x square by 2. Integral x square by 2. After integration simply add constant. So 2 get cancelled. So xy square minus x square y plus c equal to 0 is the general solution of given ordinary differential equation of first order and first degree. Solve x square minus ay dx equal to ax minus y square dy. So this is given dE. First rearrange given dE in the form m dx plus n dy. Because we have m dx equal to n dy form, we need to get m dx plus n dy to check whether the dE is exact or not. So for that I am getting the RHS term to LHS like this. X square minus ay dx minus ax minus y square dy equal to 0. X square minus ay dx. If you send minus to internal term, what happens? Minus into minus plus. Minus into minus plus y square. Minus into plus minus ax dy. So now this is exactly in the form m dx plus n dy. M dx plus n dy. Now we need to check whether it is exact or not. For that, note down first m. What is m? M is dx coefficient, x square minus ay. N is dy coefficient, y square minus ax. Now find out dou m by dou y and dou n by dou x. Dou m by dou y is equal to, with respect to y partially, don't differentiate x terms, differentiate y terms only. So here you don't have y, that becomes 0. Differentiation of constant 0. So differentiation of y is 1. You will have minus a. So similarly here, dou n by dou x. Differentiate with respect to x, differentiate x terms only, don't differentiate y. If you don't find x in the first term, keep that one as constant. Differentiation of constant is 0. And differentiation of x is 1, this becomes 0 minus a. Now see, dou m by dou y equal to dou n by dou x. Then what happens? Given dE is exact. Given differential equation is exact. Given dE is exact. Whenever dE is exact, to find general solution of exact dE, we have formula like this. Integral m dx, y constant, plus integral terms free from x, in n dy plus c equal to 0. Terms free from x. Integral m dx. So what is m? X square minus ay. But while integrating here, keep y constant. Plus terms free from x in n. That means terms do not contain x in n. So in n we have two terms. Find out the term which do not contain x. In the first term you don't have x. Note down that one like this. Integral y square dy. So now integrate integral x square is x cube by 3. Here y constant, a constant. Integral 1 dx x minus a x plus integral y square is y cube by 3 plus c So this one will be the general solution of given differential equation, which is exact. If it is not exact, what happens we will discuss next. Whenever dou m by dou y not equal to dou m by dou x. Okay? Dou m by dou y equal to dou m by dou x, this is the procedure. If it is not equal, then what to do? What is the procedure to make it exact?